I've been working on an HHO torch setup for a while, and this video is about what I've built. I made a transformer up for it from an old microwave oven transformer. I made up a rectifier setup on a heatsink, which is right now hidden behind the transformer in this view, but I'll show it after. You can see my dry cell, a side view of it, and above it the reservoir for the sodium hydroxide electrolyte, which is mounted high, so I get a good flow down into the cell. Also in the background you can see my bubbler. I'll give better views of each component. Here's a closer look at the repurposed microwave oven transformer. It's quite a large core, as it came from some sort of restaurant duty microwave. Anyway, I cut the high voltage secondary off it, as you can see, and replaced it with some 10 gauge copper wire. I'm pretty sure it's 10 gauge. It's the red insulated wire you can see on the left hand winding. The right hand winding is the 120 volt primary, which was left alone. This transformer has a big clamp on it because I cut it apart to remove the secondary, and while I've been testing and working on the HHO setup, I didn't weld the transformer back together yet, because I wasn't sure at first of how many turns I wanted on the secondary to get the correct voltage. Anyway, that is the transformer. Next up is the rectifier block that takes the AC voltage from my transformer, about 15 or 16 AC volts. I have four large rectifiers mounted on heat sinks. This is in a full wave bridge configuration. So the AC from the transformer is converted to DC for running my cell. This rectifier block is rated at 50 amps. The transformer can easily deliver 50 amps as well without overheating. Here's a look at my dry cell, a little closer look. The end plates are 1/2 inch thick Corian countertop material. It has stainless steel plates separated by foam gaskets secured with silicone. And as you can see, it's bolted together. This is basically 3 cells, one against the other, so that's why you can see the electrical connections at the top are at the ends of the cell, and the midpoints, because I have 3 cells, one against the other here. The electrical connections to the cell are as follows. Positive comes in here, and it also goes over to the 3rd cell's positive input. Negative comes in here, and it's bridged over to there. So I have 1, 2, 3 cells, each receiving the proper voltage from the power supply. Each cell contains a negative and a positive plate with 5 neutral plates in between. My electrolyte reservoir is a 1-gallon plastic jug that I connected some plumbing fittings to. As you can see here, they're attached with epoxy, sealed with silicone. This probably won't be my final version tank, but this works perfectly for testing. The electrolyte contained in with it is a concentrated solution of sodium hydroxide. Electrolyte can leave the 1 gallon reservoir from the bottom, and it flows down into the bottom of the cell. Then electrolyte foam and HHO gas produced come out the top hose and are returned to the top of the tank. The HHO gas is taken out the top here. The HHO gas produced comes out the top, goes down that vinyl hose, and arrives at my safety bubbler, which can be seen here. This isolates the gas supply from any chance of there being a flashback. If there is a flashback, I have a pressure release rubber stopper here secured by a piece of wire, so this would just pop out if there was any flashback problem. From the bubbler, the HHO produced comes out this hose, which I can then hook up to my torch assembly, which I'll show next. For my torch setup, the next thing I have is I have the HHO gas coming out of the bubbler, going into this second bubbler here. The output of it hooks up to my torch. Now the reason for this extra bubbler, right now I have it filled with methyl hydrate. This is there to act as a fuel gas and give me a little more fuel to go with the HHO, or hydrogen and oxygen, that the cell produces. By adding this liquid fuel, the HHO gas bubbles through here, vaporizing some of the methyl hydrate, giving me a fuel-rich mixture at the torch tip, which I find is much better for welding and brazing. The HHO by itself can tend to burn metals because it's extremely hot, and there's the perfect ratio of oxygen there as well. So what I and many others have found is by adding an extra bubbler, either with an alcohol like methyl hydrate, acetone will also work, and so will lacquer thinner, to provide an enriched fuel mixture. Now the torch, I have one check valve here. Gas can only flow one way in case of a blowback of any kind. Then inside the first part of the torch body, I have brass wool packed in there as another flash arrestor. I have a ball valve to let me turn the torch on and off safely without there being a pop back. And then at the very tip here, I have a MIG welding tip. This is an 030 diameter MIG welding tip. That's the torch setup. The next thing I'll show here is I'll start the whole thing up and light the torch, and we'll see what it does. Here's a look at the setup running. The torch can be seen burning. Here we can see the flow in and out of the cell, especially out, and up to the return on the reservoir. The bubbler can be seen working. And I switched over to a clear bubbler for adding the liquid fuel gas, which is methyl hydrate. I switch to a glass flask just so the bubbling action can be seen. And last, I look up the flame itself here. HHO and methyl hydrate. There is a little nickel-silver braze on stainless steel. We'll let it cool down and have a look at it. Made a pretty good braze connection. There's two quarter 20 bolts braced together end to end. Easily heat bending a piece of threaded rod. Easily bend a piece of glass tubing. And there is a nut welded to a washer, or should I say rather brazed to a washer with the nickel-silver brazing rod. I can see the surface melting and bubbling. These used to be reddish colored granite chips. We'll see what color they turn when they cool down, and I can get a better look at them. The surface is certainly melted. Basically, that heat turned them white with a few black spots, and they're quite shiny now, almost like glazed pottery. Here's a final overview of the setup today. I'm ready to put it into some kind of enclosure, and once I have, I will make another video of it. I hope this video was interesting. Also, please like and subscribe, and there'll be plenty more to come.